start. Okay, so good morning, everybody. Welcome once again to another National Geographic Learning model lesson in our series called Experience, Learn It, Use It, where we're taking you through examples of some of our different programs. And today we are looking at cheetahs and what is faster than a speeding cheetah, specifically from the Reach Higher program. Okay, so I'll talk a little bit more about the program later, but let's just get started here today. So if I advance the slide. So my name is Andrew. I'm a teacher trainer here in National Geographic Learning. I'm from New Zealand, based in Taipei. I've been working in education more than 25 years, as you can see. I'm not so young. And fun fact, just for you today, I didn't used to do sprinting like a cheetah when I was in school. I used to run middle distance races in school, like 1,500 meters, 3,000 meters. Now, can anyone in the chat box guess why I would want to run those longer distances? I'll give you 10 seconds to have a guess. If anyone can guess in 10 seconds. 5 more seconds. Okay, no guesses at the moment. But the reason I did that, the reason I did it is because a lot less people went in those longer races, and so it was easier to get into the top 3. So it was all about improving my averages, right? Yeah, increasing my chances to be on the podium. So that's the reason I did it. Okay, very good. Anyway, today, just to get started, we've already mentioned this briefly, but please set your chat settings if you're on the Zoom call to all panelists and attendees. If you're on Facebook, of course, you don't need to do that, watching on Facebook Live. And also we have the Q&A function today. Please put your questions as we go along in the Q&A function. We'll try and answer them at the end of today. Okay, great. So let's get into seeing who's here today. Now you know a little bit about me. Let's start a poll. And we're going to let people just share multiple choice. You can select multiple answers here. What age ranges do you teach? Okay, if you can just select the boxes as appropriate, and we'll just quickly see who's here today. We'll just give it another 15 seconds or so. It just gives me an idea who's here in the room today. So I can see a lot of teachers of teenagers, and some university students, and some young, oh, actually it says very young learners twice. I'm sorry, that's a mistake. The second one should be young learners. Yeah, the second one should be young learners. Okay, so we'll pause it there. We've got a lot of teen teachers here today. That's nice to see. This program I'm going through today is actually for elementary, so young learners, usually around 10 years old at this particular level. But some of the ideas, or especially the language level that we might be using today, could be very appropriate to teens as well. Okay, so yeah, so if I just share the results on screen, you can see, I apologize for the second option. That's a mistake. I'll need to fix that later. But let's not worry about it too much. Okay, stop sharing and close. Okay, so let's get into what we're doing today. As I said, Reach Higher, level 4, which is, like I said, around 9 or 10 years old, and we're doing Unit 7. Now, I'm going to switch screens and go to our classroom presentation tool we use for this program, which is here. So on the screen, you should be able to see a spaceman, okay? And the unit title here is Moving Through Space. Okay, so let's see, who would be interested in going into space? Would any of you be interested in doing that? Becoming an astronaut, maybe going to the space station, traveling to the moon? I definitely would. When I was younger, when I was a teenager, I wanted to be a pilot, like an Air Force pilot, so that maybe I could qualify for astronaut program. That was kind of the way you did it when I was younger. However, I ended up with glasses, so I couldn't do it in the end. I couldn't join the Air Force, okay? Okay, a few of us, nice, very cool. A few of us would like to do that. What would you think? So down here it says, describe how you would feel as you left the Earth behind you. You're traveling off into space. Okay, maybe we could talk about that for a little while, but we're not going to focus on that today. But the big question that we're looking at in this whole unit is, what does it take to explore space? And one of the interesting things about space is it's really big, okay? It's very, very big. Later on, if you want, I can show you a website which kind of shows you how big space is. But what does it take to explore space? It takes an ability to cover a lot of distance. It takes an ability to travel at high speed. And so first, we're going to look at speed. We're going to talk about measuring speed. Okay? Now, to do that, we need some vocabulary. I'm just moving a few windows out the road here. Close that one. So let's take a look. I'm going to skip over this particular page here. We're going to go to this one. And we're going to look at some different words. We've got some vocabulary that we want to learn for math, okay? So there's 5 words here: accelerate, height, measure, motion, and speed, okay? Now what I'm gonna do is I'm gonna switch screens to my whiteboard here. So I have the 5 words on the page here. And you can see them on the whiteboard here. So what I'd like to do is, in the chat box, can someone tell me what one of these words means? What does one of these words mean? So if we say, so accelerate, good. So Amir says accelerate is to speed up. Yeah, that's good. That's a nice one. Thank you for that, Amir. Okay. What about for height or for measure? What could we say for those 2 words? What could we say for height? So what is your height? Or what's another way to talk about? Yeah, so how tall? Good. Okay, not how long. Okay, that would be length, right? Not how deep. That would be depth or width, maybe. But height is about how tall. Very good. Okay, what else do we have here? Measure. Can anyone think of measure? If we measure something, what are we doing? So yeah, Tony, thank you. So vertical distance is height. Yeah, so measure is kind of to see how, maybe how long or how tall something is. Yeah, to know the size. Yeah, that's a good one, LaFawn. I like that one. Okay, so let's put to know size. Okay, we don't just have to measure a height or a length. We could also measure our weight. Okay, we could also measure time. Right? So there's a lot of different things we can measure, right? Good. Yeah, quantity. That's a good one, HM. Nice. So to count the quantity. Good one. Okay, now motion. This one might be a little hard. If we say motion, what is motion? Yeah, motion is your movement. Okay, what sort of motion do you have? What sort of movement do you have, right? Okay, so at the moment I have no motion, no movement, okay? But now my hand is in motion, okay? Okay, good. And speed is, I think someone said, how fast or slow, right? Okay, and with speed, like a couple of these other ones, we can give it a number, right? So which of these words are associated with numbers? So speed, we can talk about a number, right? We can say like 100 kilometers per hour, okay? What other ones can we say, if any, on this list, can we talk about with a number? Height, yeah. So my height is a number, okay? And if I measure something, then usually that means I have a number as well, okay? Very good. Okay, so by doing this, I can see that, you know, if people in my class are telling me the right sort of words and the right sort of answers to the questions, I know that you know what they mean. I don't have to spend time defining all these words for you. In your class, though, maybe your students don't know, so you have to spend more time defining the words, okay? Right, so let me jump back to the tool again here. Here we go. We can see some example sentences here, okay? So we can see, listen to the engines roar, the cars accelerate quickly to well over 100 miles per hour, right? So we can look at some of these words and phrases here. And these ones are to do with sports, okay? So you can see all of these examples talk about sport and using these kinds of words, okay? Now, I don't want to take too long to go through this, but we could get our students to practice going through these words. I know that you know these words, so I'm not going to worry too much. I'm just going to move forward to the next idea because we've got to know some vocabulary, but we also have to know how to think about some things we're doing today, okay? So today we're going to talk about comparing and contrasting, okay? So when we compare, we say how things are similar. When we contrast, we say how they are different, okay? So here I have the Earth and Mars, and I can say the Earth and Mars are both planets. Okay, they are similar in that way. However, the Earth is has a diameter of 13,000 kilometers, but Mars only has a diameter of 6,800 kilometers, okay? So we can compare and contrast these things, okay? And if we wanted, we could make a chart or a table, right? And we could talk about these things like this. Now, again, I'm going to go back to my whiteboard, and we're going to have a think about some contrasts, okay, to do with, to do with these particular animals and objects you can see on the screen, okay? So here we can see on the right, I have my language frames, compare the blah, blah, blah and the blah, 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 both blah, blah, blah. Or sometimes we can put a verb in front, okay? So we can say the car and the plane can both blah, 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 right? Okay, or the car and the plane both are whatever, or are both, okay? If we contrast, we'd say the number one does something, but the number two does something else, okay? Great. In the chat box, can someone compare two of these things? In other words, use the language frame to talk about how they are the same or similar, okay? So if I give you an example, I could say, the car and the plane are both machines, okay, for example, okay? Great, so what do we got? Nessa says, the car and the plane are both vehicles, nice, okay? What else? The cheetah and the snake are both living things, very nice. Good, what else? Yeah, there's one more. The plane and the bird can both fly, very good. Okay, now let's do the contrast one. Okay, so contrast. So for example, the human athlete has 2 legs, but the cheetah has 4 legs. Okay, the plane can fly, but the car cannot. Very nice. Yeah. Fräulein, I like your one. You're doing a comparison. All of them can move. Very true, right? Very good. Can we do one more contrast? Can we get one more contrast? Amir gave us one. The bird has wings, but the snake does not. Thank you very much, Will. Okay, good job. Now, what I want to do is let's think, how does the speed of these creatures and machines compare, right? So of these things, which is the fastest and which is the slowest? Now, notice for the plane, I'm being a little specific, saying it's a World War I biplane. So it's a plane from like 1916, right? So it's a plane more than 100 years old. Okay. So that's an old plane. The car is a modern car, today's car. Maybe it's a Volkswagen or something like that, right? Okay. The bird is called a swift. You can see the name of the bird here. Okay. Right. So which one do you think is the slowest of these particular animals or machines? Which one is the slowest? In the chat box, which one do you think is the slowest? Amir thinks the snake. The snake. Okay, we think the snake. Okay, so what I'm going to do is I'm going to drag the snake and I'm going to put him over here on the arrow. So he's the slowest. Okay. Okay. What about number 2? What about number 2? So we had a lot of people say the snake for the first one. What about the faster than the snake? The human. Okay, so we think the human is faster than the snake. Okay. What about next? What do we think the next one might be? After the human, the bird. Okay. We think the bird. Good. Okay. Remember, its name is a swift, which is a bit like something that's fast. Okay. What about number 3? What do you think the third? Sorry, number 4, the fourth one. Maybe the car. The plane. The car. Okay, we've got some debate here between the car and the plane. Are the car and the plane perhaps both a similar speed? Maybe they could both be a similar speed. I don't know, right? Okay. Well, it's a toss-up. Let me just put them together. Let's just put them together because we're not quite sure. Okay. And then does that mean we think the cheetah is the fastest? Is that what we're thinking here? Okay, so does this look pretty good? We think this is what it looks like. Tony, yeah, Tony, if you change your chat options, people can see. But yeah, yeah, it can run at a very high speed, but not for very long. Actually, a cheetah can only run at top speed for about 200 meters. Bella thinks maybe the airplane is the fastest. Okay, well, let's go down and look. And here is, actually, when I looked up the numbers, here's what it came out to be. The human athlete is slower than a rattlesnake. Rattlesnakes are faster than people. Maybe not faster than an Olympic sprinter, but faster than most people, okay? Snake is number 2, rattlesnake. Cheetah is number 3, and then the bird, the plane, and the car are all approximately the same speed, okay? So the bird, the plane, and the car can all go about 160 kilometers an hour, right? 100 miles an hour, right? Whereas the cheetah is a bit slower than that, okay? Okay, but interesting. We've got some comparisons here we can draw between these creatures and machines. Okay, and that leads us into a little bit about what we want to talk about today. So, what kind of car is it? Today's Volkswagen, right? Not a racing car, just a regular car. Okay, depends what kind of car you prefer to drive. Okay, anyway, let's go back to here again. So we talked about comparisons and contrasts. That's great. Now we do have, I want to do something before I do this. Let me go back to my whiteboard for a second. I just want to set something up in the background. So let me do this. Okay, right, now I'm going to share again. We're going to share back to here. Okay, so on the screen, we've got some academic vocabulary that we're going to learn, but I'm not showing you what the words are in advance. Instead, down here, I have 5 pictures, and if I choose a picture, then it will display a sentence, and we have to try and figure out the word. Which picture would you like to look at first? The bear, the plane, the tortoise, the map, or the puzzle? Which picture would you like? Which picture would you like to look at? Number 1, says Joy. Okay, so let's look at the bear. Okay, something is an amount that is usual for a group. Bears have an of 2 cubs. Now, hint, it says an something, which means the word that comes after it must start with a vowel. And it says it is the amount or the number that is usual for a group. Does anyone have an idea? Amir says average. Well done.
An average is an amount that is usual for a group.
Very nice. Well done, Amir. Bonus points for Amir.
Bears have an average of 2 cubs.
Very nice. Okay, let's try another one. So which one should we do next? Which one should we do next? Now, again, I wouldn't normally do this with students because they won't know the words, right? But you're adults. We can try this, right? Okay, the plane. Let's try the plane. So this is a noun. Is the amount of space between things. Today, we can fly along very quickly. Nessa says distance. Well done, Nessa.
Distance is the amount of space between things.
Very nice, Nessa. Well done. And everybody else.
Today, we can fly a long distance very quickly.
Okay, next one. Which one should we do next? We're going to do all 5. Turtle. Okay, we're going in order. Okay, the of an action is its speed. Turtles move at a slow So what word do you think? Pace. Good guess. It's not actually pace. However, it is a word like pace that has 4 letters. Okay, both pace and this word have 4 letters. See, I'm using comparisons, right? I'm using comparisons. If I teach my students something in class, I try and use that idea as many times as I can. Nessa says rate. Well done, Nessa. Again.
The rate of an action is its speed.
Very good.
Turtles move at a slow rate.
I think this is a tortoise, actually, but anyway, regardless. Okay, let's do the map next. So gives size comparisons. The of this map shows that 1 inch is 1 mile. What have we got? Diana says scale. Well done, Diana.
A scale gives size comparisons.
Very good. The scale is 1 inch to a mile.
The scale of this map shows that 1 inch is equal to 1 mile.
Okay, last one. To a problem means to figure out. When you a puzzle, it's done. Very good, Mia. Solve. Well done.
To solve a problem means to figure it out.
Very nice. You guys did a good job.
When you solve a puzzle, it's
It's
done.
done. Very nice. Okay, let's reset that back together. So here we can see this is what the students would see in their book. But now, as it says in the bottom corner here, what we could get our students to do is to talk together and use those words with each other a little bit more. Remember, these are grade 4 students. Maybe they can talk about what they're doing in math class in terms of using these words, okay? So they can say, you know, I solve a problem in math class, or my rate of going up the steps is 1 step per second, or something like this, right? So the students can practice using these words with each other, but these are the vocabulary words we're going to see in the reading very shortly, okay? Great. One last thing before we do the reading. So far we've done, what have we done so far? Let's just go back and look. We have done math vocabulary, because we need math for today's lesson. We're compare and contrast, okay, so that we can think about the thing we're going to read, okay. We've done academic vocabulary so that we can get more understanding of the types of words we're going to see in this article, okay. Not just everyday vocabulary like speed, but academic words like rate, okay. And the last one we need to do is we need to look at a reading strategy, okay. And the reading strategy today is learning to draw conclusions, learning to think of a conclusion, okay. Now, let's see how we do this. Let's just look at the bottom here, okay? So it says here, first, I notice an important idea in the text, okay? Second, I look for another idea that I also think is important. And then third, I put those ideas together, okay? Tony, this one's for grade 4 students who are doing like an English language arts kind of program, okay? Cool. So yeah, so I need to find 2 things and put them together to make a connection and to be able to say something, okay? So here, for example, it says, I read blah, blah, blah. I also read blah, blah, blah. I get to the ideas and I include blah, 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 okay? So this would be one way to do it, okay? So you could say, for example, you don't have to do it in reading. You can do it in other things too. You could say, I see that Andrew doesn't have a lot of hair. And I see Andrew has some wrinkles. So I conclude that Andrew is not under 20 years old. I think Andrew is over 40, right? Or something like this, okay? So we can use these kind of examples to model for the students how we can do this, right? Okay, so let's look at this picture. We're gonna do this without reading. We're gonna do this just by looking at the picture here. Okay, so we've got 2 people in a picture. We've got some objects and things here. So what are a couple of things we can see and then we can conclude from this, okay? So we've got, apparently at the top it says, what do Ben and Sophia plan to do? So what can we conclude here, okay? So maybe I can say, I can see a book about star notes. I can see another book called Astronomy for Kids. So I conclude that they are interested in the stars, okay? So as Amir said, the kids are into space and stars. So I'd have to give you my evidence first, right? I'd have to say, because I see this and because I see that, so therefore I think this one, okay? Put them together, okay? Can anyone else give me a conclusion that they can get out of this picture? Any others that we can do? Okay, so Will says, I see they have a telescope. They also have a book on astronomy. I conclude that they are waiting for it to get dark to look at the night sky. Well, Will, if I look in the background, I think I can see a dark sky with stars. Maybe it's already the nighttime. Okay, very good. I could also say something like, I can see some tall buildings in the background, and I can see they are sitting on grass near some trees. I conclude that they are in a city park. Okay, there we go. Okay. Will says, I can see that they're casting a shadow. Yeah, that's from the moonlight, Will. It's a full moon time. Okay. Daisy. Daisy said, I know the rest of you can't see this. She says, I can see they are sitting together. I can see they are looking at each other. I conclude that they are friends. That's a good one. I like that one. Okay, nice. Okay, so we've got some examples. So let's use that as we look at something a little bit different. So I'm going to zoom out from here. Now, the next bit we'd be going in and we'd be starting to look at the reading. But just before we do that, I want to jump back and do something else really quickly about speeding cheetahs. We said before, if I jump back to this window, we said before that a cheetah here is faster than a human athlete, right? So let's take a little look at a video just for a bit of fun. So here's Usain Bolt versus a cheetah. Usain Bolt is the world record holder at the 100 meters in the athletic race. So I'm going to switch to a video, which is over here. This comes from National Geographic Wild about Usain Bolt and a cheetah. Now, we're not going to watch it all, but let's watch a little part. If the video is jumpy, apologies for that. That's just Zoom, but you should be able to hear it okay. Okay, so let's have a listen and a watch.
In the wild, cheetahs are the perfect beast for pursuit. Their biomechanical capabilities include increased lung capacity, exceptional eyesight, and stealth.
Wow.
They too are strategic, lying in wait for the optimal moment to strike. Ultimately, their ability to accelerate like a rocket is their dominant asset. Before testing our recruits, let's try a virtual matchup between a cheetah and the fastest recorded man on Earth, Usain Bolt. In 2009, Usain Bolt set a world record, sprinting 100 meters in 9.58 seconds. That's blazing fast, nearly 28 miles per hour. A cheetah's top speed can reach nearly 70 miles per hour. Let's put a cheetah on the track for the same event. This gives a whole new meaning to the term fierce competition.
Ow.
The cheetah takes off and is quickly ahead of the entire pack of human runners. In just 5.95 seconds, the cheetah has won, beating Bolt's record by more than 3.5 seconds. Not even the most gifted sprinter can match her.
Wow, there we go. So, was that interesting? What can we conclude from watching that video? What can we conclude? Super interesting. Yeah, we can conclude that a cheetah is damned fast, right? Okay, you can see how quickly it accelerated, right? So I see how quickly the cheetah accelerated. I see that Usain Bolt got left a long way behind really fast. I conclude I don't want to get chased by a cheetah in Africa, right? I would be dinner, right? Yeah, it's like a rocket, yeah. Wow. Okay, so let's take a look. Cheetah's not real. Well, that one wasn't, but we can put a cheetah on the track with Usain Bolt. not in an Olympic stadium anyway. I have actually seen a video somewhere of a cheetah racing against, I think it was a car, but the cheetah got scared by the car, right? So anyway, now in this particular article, we are reading a math article, okay? So here it says the genre of what we're doing is a math article. It is non-fiction. It gives numbers and facts about people, places, and events. Okay. And we have a text feature in this one. We are learning about graphs today. Now, students at this level would have seen graphs in their math class. So they will be familiar, but maybe not in English. Depends what language their math class is in. Okay. But here we can see we have a vertical axis. We have a horizontal axis. We have some different things listed on here, some different animals, including a human, and the speed that they go at, okay? So we're going to look at the graphs, and we'll use this to do comparisons and some contrasts as well later on. Okay, so let's go back out, and what's faster than a speeding cheetah? Now, you can do this in a lot of ways. You can get students to read it. I'm just going to quickly read the text for you as we go through. And then we'll go over some questions and ideas together really quickly. I just want you to get a feel for the material, but in class, normally this would take a bit longer, okay? So first, before we start, up the top here, it says we're going to set a purpose, okay? So up here, it says we need to set a purpose for what we're doing today. So the purpose today is to learn about the speeds of different animals and objects in our universe, okay? So we're going to compare and contrast these things, okay? Okay, so here, very quickly, how fast is fast? You may be fast on your feet, but if you want to win races, never race a cheetah or even an ostrich for that matter. If you run very hard, you might reach a speed of 24 kilometers per hour or 15 miles per hour. That's not nearly fast enough to keep up with an ostrich. An ostrich is the world's fastest two-legged runner. It has a top speed of about 72 kilometers per hour or 45 miles per hour. In a race, though, the cheetah would certainly be way out in front. Okay, so if we look at what we have on here, we saw Usain Bolt go against the cheetah. Do you think Usain Bolt would have any chance with an ostrich? What do you think? From the number here, it says the ostrich can go 72 kilometers per hour. Yeah, I think no, right? I think that the ostrich would still be out in front, right? In fact, I think Usain Bolt's top speed at the middle or end of the race is about 45 kilometers per hour. So compare this number, 72 for the ostrich, and if I said Usain Bolt's about 45 at his maximum speed, then yeah, I think the ostrich is still going to win here. Okay, but let's look down here. I'm just going to erase those. Okay, and let's look down. Oh, go away, pen. And look down here. So here we have 4 animals. So we've got the human, of course, ostrich, cheetah. Now we've also got this one here. What is this animal? It tells us in the caption, it says a peregrine falcon. In downward flight is faster than any animal that lives on land. Wow. We haven't even learned about that yet. Okay. But we saw a couple of phrases up here that were in bold, right? We saw fast on your feet and way out in front. Now, you know what they mean, but for students who don't, then down here, we can have a short definition of what those phrases mean. Okay. So fast on your feet is a great runner, way out in front, you are first. Okay. Yeah. So yeah, actually, Amir, you're talking about the swift. Actually, a peregrine falcon is even faster than a swift. Okay. A swift is maybe the fastest bird in flat flight, level flight. A peregrine falcon gets its speed in a dive. It's a different type of flight mode, but yeah, it is much, much faster actually. Okay. Great. Okay. Okay, now over here, let's learn about cheetah. It says a cheetah can reach a speed of 113 kilometers per hour or 70 miles per hour, more than a mile a minute. No animal can run that as fast as that, okay? But a cheetah can't run as fast as a peregrine falcon can swoop. Okay, so here we can see peregrine falcon can swoop at 200 miles per hour, okay? That's 3 times as fast as a car zooming on a highway and about 3 times as fast as the cheetah, okay? So if we are comparing the cheetah and the peregrine falcon, we can say a cheetah is fast, but the peregrine falcon is faster, right? We can also say a peregrine falcon is about, it says here, 3 times as fast as a cheetah. Because why is it 3 times as fast? Now here you can draw on a little bit of math and you can say, well, if I take 70 miles per hour, 70, and I multiply it by 3, then, well, that would give me 210, which is pretty close to 200 miles per hour, okay? So you can show the students what that phrase 3 times as fast means just using some simple math, okay? Great. Okay, so let's see. Now let's look down at the graph here. It says at the bottom, a peregrine falcon is magnificent. It can dive faster than any creature can run, but it can fly as fast as an airplane. We'll learn about airplanes in a minute. Now, if we look at the graph here, we can compare and contrast the creatures on the graph here. Now, there's something interesting on the graph. Here on the graph, if I just highlight it, here we have a brown box. And here we have this kind of bubble. What do you think the brown box and the bubble are trying to show us? What do you think those things are trying to show us? The brown box and the bubble. Very good, Amir. Yeah, so one's on land. Okay, so this one is on land, right? And this one is in the air. Okay, so the graph is giving us more information about how those creatures move, where they move. Okay, very nice. So what's a compare or contrast statement we could make about this graph? And I could get my students to do this. Okay, so we could say the human, the ostrich, and the cheetah all move on land, for example. Or the cheetah moves on land, but the falcon flies in the air. Okay, great. Okay, we could also talk about the speeds. The ostrich is 3 times as fast as the human, right? But the falcon is about 4 times as fast as the ostrich, right? So we could make statements like this as we go as well. Okay, so let's clear that one. Now, the next page, what I'm going to do is, before we continue, actually, there you go. So down the bottom, you can see these are the questions I've already gone over about the graph. Okay, I've already talked about what's a question about the information or how much faster can we run. We've seen those already. Okay, let's go to the next page here. Now, I want you to read this one by yourself. I'll give you a moment to read it by yourself. And then I'm going to ask you to compare or contrast a couple of things here. So take a moment, read the text. Check my time here. Okay. Okay. So here we're talking about planes with a propeller. Okay, that's the thing that goes around on the front. The jet engine planes, right? And sound waves. Okay. So if I say, can you compare and contrast the propeller plane with a jet plane, a jet engined plane? Okay. Okay. In the chat box, can you make a compare or contrast sentence about the 2 types of plane? What could we say? I'm pausing and waiting patiently for the chat box. Okay, yeah, we could say the jet plane flies faster than the propeller plane, or the propeller plane flies fast, but the jet plane is even faster, right? Okay. Okay, what else could we say? What's another thing we could say to compare or contrast these? Thanks, Nessa. Nessa, if you change your chat options just above where you type, then other people can see what you're typing as well. Yeah. Any others that we can say? So maybe I could say, for example, both, yeah, we could say the jet is 2 times faster than the propeller plane, Joyce. Yeah, we could say that, okay. Depends on the plane. Some jet planes are very, very fast, right? Okay, so what else could we say? The jet and propeller plane are both can fly. That's true, Tony. And they both can fly faster than a peregrine falcon. That's true. Okay, thank you, Tony. Good. Now, again, we have the graph. So if we go down to the graph here, we can see 4 things on the graph. We can see the peregrine falcon, propeller plane, sound, and a jet plane. Okay. Now, of course, different types of planes can fly at different speeds. Now, I have a question for you. This is a science question. Maybe it's something it's not about the article. It's just, do you know or do you not know? So what do you think? If I have a propeller plane, so if I have sorry, too many things on my road here. If I have one of these kinds of planes, a propeller plane with the propeller on the front, can a propeller plane go faster than the speed of sound? What do you think? Is that possible or not possible? So everyone here currently is saying no, 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 no. Okay. Does anyone know why? Does anyone know why that might not be possible? Any ideas why? Yeah, part of the problem actually is the way propellers work with the air. And when the air gets too fast on a propeller, it doesn't work, essentially. Once you're going a certain speed, the propeller just can't push you any faster, okay? Because of the way propellers work. Also, when you get close to the speed of sound, your plane starts to vibrate, and actually it can rip the propeller off your plane, which would not be a good thing. So yeah, jet planes can go faster than sound because their engine is very different, right? They are superheating the gas inside the engine, and they slam it out the back, almost like they're pushing the air out the back, almost like a bullet out of a gun, okay? And so they can, because of the design of their engine, yes, they can go faster than the speed of sound, okay? Yeah, so propeller plane is a limit. It's kind of a mechanical limit, okay? You just really can't get a propeller plane to go that fast, okay? Yeah, okay, very good. So we've learned some information from the thing here. I'm just getting rid of the pen. Okay, now down here at the bottom, it says a sound wave travels through the air, right? So if I'm talking to you and I'm here, like right now you're hearing me out of your computer, it's going through the air to get to your ear. I have a question for you. Here it says a sound wave. What do you think a sound wave looks like? What do you think a sound wave looks like? So if you think of a wave, you might think like a wave on the beach, right? Which looks like this, right? Like that. Do you think that's what a sound wave looks like? What do you think? Does it look something like that or not? Okay, some people are saying no, okay, and you are correct, okay, because there are actually two types of wave, okay? One type of wave goes up and down. As the wave is going across, it goes up and down like this, right? The other type of wave as it goes across, it goes backwards and forwards like this, okay? So instead of doing up and down, it does this, okay? And the one next to it will be doing the same thing, right? And if you have a speaker on a stereo or a radio, and you look at the speaker, you can see usually it's black in the back, and you can see it moving backwards and forwards towards you, and that's the sound coming towards you, right? Interesting. Okay, so a little bit off topic, but that's okay. We're having fun. Okay. Okay, now faster still over here. Okay, now this is interesting. If you shouted to someone who is traveling faster than sound, your voice will go fast enough to catch up to them and they would never hear you. That's kind of interesting, right? So what does that mean? If you're in a plane going faster than sound, if you're in a jet plane going faster than sound, can you talk to the person beside you or not? Do you think you can talk to the person beside you if you're in a plane that's faster than the speed of sound? You can. Yes, you can actually. So you can. Now, why can you do that? Because I thought they said if you shouted at someone and they're traveling faster than sound, then the sound won't catch up with them. How does that work? What's the logic there? Okay. Well, the logic there is actually you're both moving together and the air that's around you is also moving with you. So actually, compared to each other, you're not actually moving faster than the speed of sound. You're actually moving the same, okay? So yeah, you're in the same plane, so that's okay, right? Now, here's another thinking question for you. If I have a plane traveling faster than sound and it's coming towards me, can I hear it before it gets to me? Can I hear the plane coming? So people think yes in the chat box. Well, how does that work? Because if the plane makes a sound over here somewhere, and then it travels to here, doesn't it get there faster than the sound gets there? Doesn't the sound end up behind the plane? Yeah. If it's traveling towards you, actually, you won't hear the plane until it's on top of you. Right? Or just above you, and as it goes past you, and then as it goes past you, it's like you hear nothing, you hear nothing, you hear nothing, and then all of a sudden, boom, you hear the sonic boom as the plane goes flying past you, okay? So the sonic boom, it's, yeah, like someone just said, Tony just said, it's like thunder, right? You see the plane goes past you, and then later you hear the sound because the plane is traveling faster than sound. Tony, that's a really good analogy, good job, okay? Very nice. Okay, now we're running out of time a little bit today, so I knew we weren't going to get through the whole article, but let's take a quick look at some other things that are in here today, right? So faster still, down here at the bottom it says, can we compare the jet with the speed of sound, which travels faster, right? And what about a rocket ship? If you want to leave Earth and go off into space. What about a rocket ship? It goes even faster, 40,000 kilometers per hour. Wow, that's pretty damn quick, right? Okay, let's take a look at the next page. Just quickly looking at what's here. When we're in space, it says here we can just coast in space. There's no air to have drag, like the ball here is affected by drag in the air, which is why the ball slows down as it's moving forward and why a pitcher can make it do crazy things in baseball, okay? But when you're in space, it doesn't do that. There's little or no drag in space. There's no friction from the air in space. Wow. So spacecraft can go a lot faster than planes because of that reason, okay? And also meteoroids can go even faster, 240,000 kilometers per hour. Wow, that's moving, okay? Okay, what else have we got here? Next page. Okay, so here we're comparing a jet plane at a really, really slow 1,300 kilometers per hour. I think this is actually miles. Oh, it's miles per hour at the bottom, with a rocket ship with a meteoroid. Wow, so much faster. Okay, very nice, right? Okay, now are these the fastest things there are? Do you think there's anything faster than a meteoroid? Do you think there's anything faster? And the answer is actually yes, there is. Yes, there is, right? Because actually the fastest thing in the universe is light. Well, at least as far as we currently understand, okay? The fastest thing we currently know of in the universe is light. And light travels at this speed, here we can see, almost 300,000 kilometers per hour, per second, not per hour, per second. Wow. So that means if I go back to the previous page, so the meteoroid was 150,000 miles per hour. If I go look at this one is 186,000 miles per second. That's thousands of times faster, right? Light is so fast. Light is so fast, a beam of light could circle the Earth more than 7 times in 1 second, right? So you send an email to your friend, it travels by light inside something called a fiber optic cable, and that email could go around the world like 7 times and get to your friend's inbox in a second, right? If it wanted to do that, okay? Crazy. And then down here, we can compare. If I wanted to go to the moon, how long would it take me? So if you want to run to the moon, it would take you almost 2 years. If you're a cheetah and you can go at top speed the whole time, it's still going to take you almost 5 months. A jet plane is going to take you a week to get to the moon. A rocket ship, it says it will take 9.5 hours to get to the moon. Light takes a little over 1 second to get to the moon. Wow, so some interesting things we can do here as we're looking at this reading, okay? We can contrast and draw some more conclusions out of this as well. Okay, now I have one final question for you to have a think about here. If I said down here, this is a little interesting, right? This one's a little interesting. It says here, a rocket ship can get to the moon in 9.5 hours. 9.5 hours. Okay. Does anyone know how long it took NASA to send Neil Armstrong and the others to the moon? So Will says it took 3 days. Okay, so is NASA lazy? Is NASA slow and lazy? Why, as Will said, yeah, for NASA to get men to the moon, it took 3 days. Now, why do you think there's a difference between 9.5 hours here and it took NASA 3 days? Do you think NASA has rubbish rocket ships? Right? Do you think Elon Musk can get them there faster with SpaceX? Right? Comfort break, says Amir. Yeah, they're taking a toilet stop. No. The moon is moving, says Will. Okay. Well, can't you just like intercept the moon on the way past? Technological limits, says Joy. The orbit, says Joyce. Well, actually, Joyce is the closest so far. Yeah. Okay, would you like to know why it took NASA 3 days to send men to the moon? Yes, we would, says Joy. Okay, I'm going to go to my whiteboard again so that I've got some space to draw. let's go to here, and let's go down here, and we'll talk about, yeah, Tony's got, yeah, you guys are kind of getting the idea. Okay, so here's a picture. Here's the Earth, right? Here's the Earth, and here's the moon. We want to get to the moon. Now, obviously, the moon is moving, and it's going around the Earth. It's going around the Earth in kind of a circle, right? So it goes around the Earth, something like that, right? That's the orbit of the moon. Okay, now, do you think it's possible that we could just say, well, the moon is going to move over to here in the same time that I'm going to go that way like that, and so I could get there in 9.5 hours, right? Okay. Could we do this? And the answer is, well, yes, maybe we could, but we have a problem. We have a problem here because the Earth is, the moon is moving in a circle, right? What's the Earth doing? What's the Earth doing? The Earth is spinning, says NASA. Yeah, more importantly than just moving, the Earth is spinning. So actually, when we launched a rocket, the Earth is rotating, something like this. So when we launch our rocket, what we do is we don't go that way. What happens is we launch the rocket, but as we launch the rocket is essentially moving like the Earth does, because the rocket starts on the Earth, and as it moves up, it spins with the Earth, right? And so the rocket goes that way like that, okay? And we've now got an option. We can either accelerate the rocket in the way that we're going, or we can try to decelerate the rocket so that instead of going sideways, that we go more straight up like that, okay? This one has a problem. It takes too much fuel, okay? It's too hard to get the rocket to do this one. So what we do instead is we just accelerate the rocket kind of the way we're going, and then eventually, 3 days later, we'll get to the moon, okay? So when you go from the Earth to the moon, you don't go in a straight line, you go in a spiral, and you get to the moon that way. And that's why it takes 3 days, okay? There you go, so now you know. Okay, very good. So I hope that was kind of useful. I've gone off topic a little bit, but when you have students who maybe have interest in some of these areas and you want to explore the idea more, as well as reading on the topic, we can diverge and have discussions on other things, and we can keep going back to those same things we learned. So again, if I jump back to the book, I share back to here, and I go back to the beginning of the book, go back to here again, right? Jump back some pages. Then what I've been trying to do, even when I've gone off topic, is off the topic of the story at least, I'm trying to use these kind of math vocabulary words, right? About measuring things and the speed and accelerating. I'm trying to compare and contrast, okay? And I'm trying to use these things like distance, and maybe I haven't yet used the word scale or rate very much, but we're trying to use these words as we're exploring these topics with the students. Now, if the students don't like that topic, they don't want to go on that path, okay, let's go back to the book and maybe we can find something else that they're interested in as a way to engage them and keep them going, right? Okay, but yeah, you can see here there's a lot of different reading ideas here that we can go through with the students. Sorry, a lot of different things in the reading that we can share with the students. This one's a really good one for facts and things that are interesting. The students probably won't know all these facts, and so there's a lot of things you can engage the students with here as you're going through this particular story, okay, with them, okay? Afterwards, so you know, there are activities, and there's a practice book as well with other activities and things in as well. So if I just open the practice book, we have things like compare and contrast pages and things like this as well. But lots of activities your students can do, okay, as we go through this material. So I hope you found that interesting. Let me jump back to the PowerPoint now. So just to wrap up, I've got a couple of minutes here. So yeah, what we did today, we talked about the Reach Higher lesson. Just so you know a little bit about it, it's a 6-level international standards program designed for elementary school students doing kind of English language arts, right? So maybe the students are in international school, or they're studying English like 4 hours a week, and they want, you know, lots of English like people might learn in, say, Canada or Australia or the UK, that kind of international standards English, okay? It teaches language and literacy and uses a lot of content, Okay, we're using authentic content to teach language and literacy. Okay, so here today, what were some of the things I was doing? We were looking at academic vocabulary. We were doing comparing and contrasting. We were using comparison charts. We were looking at graphs and things. We're trying to do discussions and Q&A about different things with this as well. And using text features like graphs, looking at graphs and math article genre. So lots of different things we're trying to do here with the students. Now, if you'd like to find out more about this particular program, I'm opening up a poll. Here we go. If you would like to find out more about this program, just tick yes, and I will send you some more information tomorrow. So you can see more about this program. If not, that's fine. I won't send you the extra information, obviously, if you say no. But if you say yes, please, then I'll send you some more information. Okay. Great. Thank you for those who say it was good fun. Okay. I'm going to leave the poll running and just I'll jump to the next slide real quick. So here we can see what happens as a follow-up from today. So I know a lot of you have been to our webinars before, but if you haven't, there will be a survey. Now today, this is a little different. When you close the Zoom call, it will take you straight to a survey. It has 2 questions. It just wants to know what you thought about today's webinar. And then tomorrow, I will send you a follow-up email, which will contain your certificate, as well as the recording link from the session. So if you want to watch it again or share it with other people, you can do that. Okay, so there we go. So this one here, the follow-up email, that's tomorrow. The survey you will see straight away when you leave here in a few moments. Okay, great. So thank you for that. And just, yeah, I guess a couple of minutes left. Does anyone have any questions about it? I can see there's nothing in the Q&A box, which is okay. But in the chat box, if you've got questions, more like this, please, says Tony. Tony, do you have any specific requests? So Joy asked, what's the name of this book? The name of the title or the series is called Reach Higher. Okay, that's the name of the series. You like the science topics? Okay, that's good. I'll make a note of that for later. You like the science topics? Good. Other things like in this book as well, it has things to do with history, has things to do with social science, social studies, in this particular book. And in some of our other materials, we have these topics as well. Okay, Reach Higher, if you're teaching it in an ELA situation, Bella, then normally you would use it for grade 1 to grade 6, normally. You don't have to though. I've used this material with students like 1 grade later sometimes. So if I have a grade 4 student, I give them the level 3 book because that might be more appropriate for them. But yeah, there's a lot of ways to do it. But traditionally, if you're doing it in an English language arts program at an international school, grade 1 to grade 6 for the 6 books in the series. Okay, let's see what else is in the chat box here or in the Q&A box. Topics on elementary mathematics. Actually, Grace, because for National Geographic Learning, we tend to focus on language teaching. And the method today was doing language teaching using content from a science or math article, right? So the parent company for National Geographic Learning is called Cengage. And Cengage, which is in all of the countries that we are as well, does have mathematics topics, does have science topics and history, and a lot of those other things. If you want to find out more about that, drop me an email. You've got my email because of the reminder emails about the webinar, and we can introduce you to some people who work for the Cengage company that do those kind of mathematics topics and so on, things like that as well. Okay, Ben Howard is asking, can we have a topic about classroom management? Okay, whoa, excuse me. Sorry, I didn't mean to do that. Here we go. Oh dear, there we go. Okay, I'm trying to write classroom management. Always a good one. Okay, so that would be more of a teaching practice one rather than a model lesson, right? But yeah, I think we can do that. We'll talk with the team and figure out how we can do that. Let's see, any other questions? I'm just looking in the chat box. Thanks, Will, for dropping that one in there. about the webinars. Yeah, so you can sign up for more webinars. Will has a webinar coming up next week on World English. You can see it here. You can sign up for it now. The ones that are coming up in the future, January, Kitty will be doing Our World. And then Will also be doing a program called Look. Our World and Look are young learner programs. World English is an adult program, okay? So we'll tell you more about those ones next week as well. Okay, so thank you very much, everybody. I think I'm just trying to scroll through the chat box, see if there's any other things there. Okay, very good. Well, thank you, everybody. I hope it's been good today. We'll let you get away. We're right on time. So enjoy the rest of your day. And now you know more about speed and pace. I hope that you have a very productive day where you can produce a lot of stuff at high speed and that you produce a lot of good work today in whatever you're doing. Okay. Thanks very much, everybody. We'll see you again soon.